Hi, my name is Jake Wiltgen, Solutions Director within Siemens EDA's Digital Verification Technologies Division. I'm here in Colorado, up at the Red Rocks on a fabulous Colorado morning, enjoying a short little morning hike, and thought I would just pause, take a moment, and discuss some of the emerging and evolving DFT verification challenges that industry faces today. So let's dive in. First, it's worth mentioning that DFT hardware is offering more capability than ever before. There's test data delivery over high-speed parallel bus, uh, high bandwidth IJTAG, hierarchical ATPG flows to support scaling to large SoCs, in-system tests for remote and in-field diagnosis and analysis. And so with all this capability does come complexity, and verification is directly impacted by that complexity. From a verification standpoint, there's certainly your core level and top level ATPG simulations that take hours and days for parallel, days to weeks for these long running serial simulations. You multiply that across different configurations, different fault models, zero delay, and timing across the corners. And overall, what we're seeing in the industry is this growth in the amount of verification volume that is required to achieve DFT sign off. And to complicate matters, DFT sign off, those final DFT simulations, are often the final things that are run before tape out, and they become a gating factor to tape out. So it's important that we look at all of the different options available to us from a simulation technology standpoint to bring in the time taken to finish those final DFT simulations so it isn't a tape out blocker. There are a number of verification technologies that exist today that can help with DFT simulations. On the general purpose side, there's model pre-compilation and optimization to reduce the impact of compile and op times on your overall simulation runtime. There's checkpoint restore capabilities to uh, reduce the impact of common setup across your different types of simulations. And then there's multi-threading and multi-core capabilities to really leverage the and take advantage of all the compute resources that are available within your data centers. In addition to the general purpose, there's also DFT-centric capabilities. So with an understanding of the unique nature of test infrastructures, test architectures, specific DFT optimizations are now being built into simulators to reduce the impact of both those shorter parallel simulations as well as those very long running serial scan simulations. There are a number of verification technologies that have been explicitly developed for DFT. On the compile and op side, there's the ability to now dynamically swap in different DUT views based on the test intents, particularly useful in retargeted pattern simulations. We've also built in a number of DFT specific optimizations, leveraging our unique understanding of test architecture, test implementation. And so with this deep understanding, we've been able to put in optimizations that provide an evolution in simulation performance across both parallel and serial simulations. There are a number of verification technologies which exist that can help with the core DFT careabouts. In scenarios where in markets where extra high reliability is a requirement, and you're not quite hitting that defect coverage with structural scan, fault grading is a great complementary solution to evaluate the effectiveness of functional patterns and identify how much additional coverage those functional patterns give you. Additionally, silent data corruption, it remains a focal point in the industry, manifesting itself as data loss, data corruption, performance degradation, often very hard to detect and debug. And so a deep structural analysis, leveraging some verification structural analysis capabilities alongside fault grading provides a great flow for understanding the effectiveness of software-based detection and mitigation strategies. So the rapid adoption of in-system test to assess silicon health, to do in-field and remote diagnosis and debug, has created a new paradigm in the context of DFT verification. So unlike traditional DFT verification, there's now this complex ecosystem of hardware and software responsible for moving data from memory, from off chip, into the scan chains, and then pulling that data back out for analysis. And so from a verification standpoint, project teams and engineers need a comprehensive hardware software co-verification environment that runs real software against the real hardware and ensures that that behavior is functionally correct. So I hope you found some of that useful. If you have any questions, please don't hesitate to reach out. As you may have heard, back in May of 2025, we launched Questa 1, and part of that was Questa 1 DFT simulation. And so all of the challenges that I mentioned in this video, all of the technologies that were mentioned to help solve some of those challenges are now built into the Questa 1 DFT simulation, providing orders of magnitude total productivity, simulation performance. And so if you're interested, if this is a pain point that you're experiencing, please reach out and let's have a discussion. Thank you.